right, so today we will be graphing inverses. And so we've talked about inverses before. And so we know that the inverse of a relation that is called R, we'll write it as R inverse. And so to find the inverse of a relation, so that's before we know that it's a function, we'll switch our x and our y values. So here where it says one-to-one relationship, if it is one-to-one, that means both R and the inverse of R are functions. So here's an example of a relation R with several points in our set. And so when we're writing the inverse, we'll take that set and flip our values. So now this is -2, 1, 4, 2, -1, 3, and -2, 4. So is R a function? My original R. We look at the x values, and they're 1, 2, 3, and 4. So yes, R is a function. None of our x's are repeated. And then is R inverse a function? So we've got -2, 4, -1, -2 as my x value. And I see that -2 shows up twice. So no, R inverse is not a function, meaning R is not one-to-one. So if either of your answers are no, then the last answer will be no. On number 2, we're going to do the same thing. So we're going to make our inverse by switching our x and our y values. Looking at the original R, we have 1, 1, 3, 4 as my x values. So R is not a function because I repeated 1. Then with R inverse, we have 5, 6, -4, and 9 as my x values. So R inverse is a function because I didn't repeat any x values. But since the original one was not a function, R cannot be one-to-one. Now number 3, we're given our relation as a mapping. So R inverse will take 2-1, 6-0, and 6-11. So in order to do that, I moved my arrows to the opposite direction and started with these values. You could have written out the original points as well. We have 0, 6, 1, 2, and 11, 6. Then is R a function? Looking at just our x values, do any of them repeat? No, so yes, it is a function. Then is R inverse a function? No, because we see that 6 is an x value twice, so R is not one-to-one. So remember that we use the vertical line test to determine whether a relation is a function if we're given a graph. And then the horizontal line test will be used to determine whether the inverse of a relation is a function. So since we switch our x's and our y's, instead of using a vertical line test, we'll use a horizontal line. And then remember that it has to be a function as its inverse and as the original relation in order for it to be one-to-one. So on number 4 and 5, we're determining whether it is one-to-one. So we're going to use both the vertical line test and the horizontal line test. So we just draw our lines anywhere. I only pass through one point, and I only pass through one point. So this is the horizontal line test, which checks the inverse. And this is the vertical line test, which we're used to using. So since they both only pass through one point, then we would say, yes, this is one-to-one. Then on number 5, we'll do the same thing. I'm going to pick any part of the graph to write my vertical line through, and I see that I'm only passing through one point. So it passes the vertical line test. This is a function. And then when I draw on my horizontal line, I'm crossing 3 times. So it does not pass the horizontal line test, which means it is not one-to-one. Now when we are finding the inverse of a function, this is where we replace our f of x with y, then we switch our x and our y's, and then we will solve for y and rename it as the inverse of f of x. So the inverse of a function we write as f inverse of x. So on number 6, we've got f of x equals 5x. So in order to find the inverse, we'll rewrite that as y equals f of x. Then switch them, and then solve. So I get x divided by 5 is y. Since y is by itself, that's my inverse. So f inverse of x is equal to x over 5. Number 7, we'll do the same thing. So this is now y equals x minus 7, just so I can switch them. So x equals y minus 7, and then I'll add 7 to get it away from that y. X plus 7 is equal to y. Since y is by itself, that's my inverse, so the inverse of f of x is x plus 7. Then on number 8, this is y equals x minus 8 all over 3. We'll replace them, so x equals y minus 8 over 3. And I want to get the x, I want to get the y by itself. So first thing I'm going to do is multiply by 3. I get 3x is equal to y minus 8. So let me rewrite that. I'll add 8 to both sides. And 3x plus 8 is equal to y. Y is now by itself, so that's my inverse. F inverse of x is equal to 3x plus 8. I personally find finding the inverse quite fun. So once you get the hang of it, I do think it's something that's kind of satisfying, like the way that synthetic division is satisfying. So this is x equals negative 2/5 y plus 1. And then we're solving for y, so we'll remove that 1 first. We get x minus 1 is equal to negative 2/5 y. And so at this step, we can either multiply by the reciprocal, or we can multiply first, then divide. It'll end up doing the same thing, so I'm going to take everything and multiply by the reciprocal. So negative 5 over 2 times x minus 1, negative 2/5 y times negative 5 over 2. So we get negative 5 over 2 x plus 5 over 2, and that equals y. We can write it as negative 5x plus 5 all over 2, or we can write it how we had it, where y equals right here. Either way, we can put it as one fraction, or we can separate it with 2 fractions. Same process on the next 2. So I'm going to switch my x and my y's. And add 9. I get x plus 9 equals y squared. I have to undo that square, so I'll take the square root of both sides. The square root of x plus 9 is equal to y. So y equals the square root of x plus 9. Now, whenever we're doing square roots from a square, remember that a square function looks like that, but a square root function looks like that. So in order for us to get both sides of it, we do have to take plus minus. So the inverse function will be both the positive and the negatives of x plus 9. Because when we take the negative sides of that, it'll complete it that way. Now on number 11, we have y equals x plus 4 cubed minus 6. So we'll switch our x's and our y's and solve for y. So first thing I'm going to do is add 6 to both sides. X plus 6 equals y plus 4 all cubed. I'll take the cube root. I get cube root of x plus 6 equals y plus 4, but I need that 4 gone, so that leaves me with the cube root of x plus 6 minus 4. Make sure it's not underneath the radical. That equals y, so my inverse function is the cube root of x plus 6 minus 4. With our cube root functions versus our cubic, sorry, I could not think of the word. Remember that the cubic looks like this, and then the cube root looks like this. So both sides are there, so we don't have to do a plus minus in that situation. Now, whenever we're verifying if two functions are inverses, we will use composition. So two functions f and g are inverse functions if and only if f of x, nope, f of g of x, there we go, equals x, and g of f of x equals x. So I do think we've talked about this briefly before. So on number 12 and 13, we're determining whether they are inverse functions. So we will take the composition of f of g of x, which is x times the square root of x minus 8. I'm sorry. We're replacing x, there we go, with all of this. So we have the square root of x minus 8 all squared plus 8. And the square root of something squared gets rid of the radical. So we have x plus 8 plus 8. Oh, x minus 8, I'm sorry. And that is x, since the negative 8 and the positive 8 will cancel. So we have that one. But we do have to check both. So g of f of x. So instead of writing x in our f function, we're going to write, instead of writing x in our g function, I was doing the first one again, we're going to write all of what f is. So we would have the square root of x squared plus 8 minus 8. And then already we have that plus 8 and minus 8 canceling, which leaves us with the square root of x squared, which is x. So both of them equal x, which means these are one-to-one, not one-to-one, these are inverse functions. So if something said, prove that this is an inverse, or determine whether they are inverses, this is what we're expecting you to do, not just find the inverse and say, well, yeah, that worked because I found the inverse and that's what it is. You do need to prove it using composition. So we'll do the same thing on 13. F of g of x. So we're replacing our x with the function g. So negative 4 times x over 4 minus 5 plus 5. So we're going to distribute that negative 4, which gives me negative x on the first term, and then plus 20 on the last term. And then we have that plus 5 on the end there. So we get negative x plus 25, which does not equal x. So f of g of x didn't work. And so we could stop there and say they're not inverses. But we are going to show the second one. So g of f of x means we have negative 4x plus 5 all over 4 minus 5. So instead of writing this x here, I wrote this entire function in. And so we would have negative x plus 5 over 4 minus 5, which is negative x minus, this would be 20, so minus 15 over 4, which does not equal x. So I know that they are not inverses. And so today's assignment is a quiz on Canvas. So make sure after watching this video that you jump onto Canvas and watch that and take that quiz. And then you'll be done for the weekend, and I will see you guys in the next video on Monday.